Equations with distributive property notes. The learning goal is to know how to solve equations with parentheses by applying the distributive property. When solving equations with parentheses, apply the distributive property to simplify the equation. So if we look at example A, we have an equation and there are brackets, parentheses, and in order to simplify this equation to then isolate and solve for x, we're going to apply the distributive property. So the distributive property states that for three numbers a, b, and c, a, b plus c in parentheses is equal to or is equivalent to a times b plus a times c. So we multiply the numbers inside the parentheses with the number outside the parentheses. And as you're doing that, also ensure that you're following the double sign rules. So if you have two positives, so a positive times a positive, or if you're adding two positives or dividing, you'll have a positive. If you have two negatives, you also have a positive. Positive and a negative makes a negative. Negative and a positive makes a negative as well. So let's take a look at A. We're only going to apply the distributive property to simplify the expressions. So if we take a look at the expression on the right side, there's nothing to simplify as there's only one term. But on the left side, there are parentheses. So we're going to apply the distributive property to eliminate them. So we'll use the rainbow method. So 5 times x is 5x. 5 times positive 3 is positive 15, which is equal to 25. Example B, negative 4 times x, and then negative 4 times negative 5. So negative 4 times x is negative 4x. Negative 4 times negative 5 is positive 20, is equal to 8. For example C, so negative 3 times x and negative 3 times positive 4. That is negative 3x minus, because a negative and a positive makes a negative, minus 12 is equal to negative 10. And just rewrite the rest of the equation. So now we'll go over the steps to solve equations with parentheses. So step number 1, simplify the expressions in the equation. So if we look at the example to the right, we have expression on the left side of the equal sign, and then the expression on the right side. For now, we only have to simplify the expression on the left side, as the one on the right is already simplified. There's nothing to add or subtract. So part A states, apply the distributive property to remove the parentheses. So let's apply step 1A to the example of the question here to the right. I'm going to draw the rainbow. So 1 over 5 times 3x and 1 over 5 times negative 20, which is equal to 3 over 5x minus 20 over 5. And then I'll rewrite the rest of the equation. Equals 18. So now I have two terms here that are like terms in the expression on the left side. So I have 3 over 5x and negative 4x, and then my constant, negative 20 over 5, and that's it on this side. We're not going to add or subtract or combine with the terms to the right. We're just simplifying one side at a time. So I'm going to rewrite that by grouping the like terms. So 3 over 5x minus 4x and minus 20 over 5 equal to 18. So now I have two terms here that are like terms because they're variable parts, which is the x and x, so they're exactly the same variable with the exact same exponent, the invisible exponent of 1. So I'm going to now add two coefficients together. So now if we look at the two coefficients, one is a 3 over 5 and the other is 4 over 1. So in order to add and subtract fractions, I need to have the denominator to be the same. So I'm going to turn the 4 coefficient, or negative 4, into an equivalent fraction so that my denominator is 5. So right now it's technically over 1. So I need to multiply this by 5, the numerator and the denominator. So I'm going to multiply this by 5 over 5, which will then give me 3 over 5x minus 20 over 5x minus 20 divided by 5 is 4. So I'll just reduce that fraction. I could have reduced it earlier. Is equal to 18. So 3 minus 20 is negative 17 over 5x. Minus 4 is equal to 18. Next step here, after we've combined the like terms in each expression, so the expressions on the left, I have also added and subtracted the coefficients of terms with the same variable parts. And there were no constants here to add or subtract, but sometimes you might have them as well. So we're going to go to step 2. We need to add or subtract to remove the constant on the side where the variable is. So the variable here is on the left side, so I need to eliminate or remove the negative 4 by using the inverse operation of negative 4 is positive 4. So I'm going to add 4. I'm going to add 4 to the other side. So the 4's on the left side are removed. So now we have negative 17 over 5x left on the left side, which is equal to 18 plus 4 is 22. So now I have a coefficient of x, which is a fraction, equals 22. So let's look at the next step, because there are no more constants here. On the left side, the term with the variable has been isolated. Step 3, multiply, divide to remove the coefficient. If it's a fraction, multiply by the reciprocal. So in this case, it is a fraction, the coefficient. So we're going to multiply both sides by the reciprocal, which is 5 over negative 17. And I need to balance the equation, so whatever I do on one side, I'm going to do to the other. So the coefficient now, 5 over negative 17 times negative 17 over 5 is equal to 1. So 1x, we can just simply rewrite it as x is equal to, and 22 times 5, so we're looking on this side, 22 times 5 divided by negative 17 is equal to negative 6 and 8 over 17. Solve the equations below, show all your work. So if we look at this equation, we have parentheses, so we're going to use the distributive property to remove them. So 5 plus 3 times x is 3x, plus 3 times 4 is 12, which is equal to 11. And here I have 3 terms, and the 2 like terms here are constants. So the 5 and the 12, positive 12, and I have positive 3x, which is the term with the variable. So I'm going to group them. So 5 plus 12 plus 3x is equal to 11. Now I'm going to combine my like terms. The 5 and the 12 are constants, so that is equal to 17 plus 3x, which is equal to 11. So now I have a constant on the left side. I'm going to eliminate it because I want to remove the constant on the side of where the term with the variable is. So I'm going to subtract because the opposite operation of the imaginary positive here would be subtract 17. What I do to one side, I will do to the other side, which will lead to 3x is equal to 11 minus 17 is negative 6. So now I have the coefficient. So we're looking at step 3. We have a multiplication between the 3 and the x. So I'm going to divide by 3, by the coefficient. And what I do on one side, I'll divide the expression on the right side by 3 as well, which is equal to, x is equal to negative 6 over 3 is negative 2. So let's look at example 2. We have two expressions, one on the left, one on the right. And this expression on the left is the one we need to further simplify. So to remove the brackets, I need to apply the distributive property. So it becomes 7. Negative 6 times 2 is negative 12x. And negative 6 times negative 8 is positive 48, which equals to 31. So I'm going to group my like terms. So the 7 and the 48. And then I have my negative 12x. And now I'm going to combine my like terms, which are the constants. So 7 plus 48 is 55. Minus 12x is equal to 31. I'm going to eliminate the constant on the side of where the variable is, which is the 55. So I'm going to subtract the 55 on both sides. Then I can rewrite negative 12x is equal to 31 minus 55 is negative 24. So now I'm going to divide both sides by negative 12, because negative 12 divided by negative 12 is 1. Therefore, I'm isolating the x. And negative 24 divided by negative 12 will give me x is equal to positive 2, because a negative divided by a negative gives me a positive. Question 3. The perimeter of the square is 28 units. Find the value of x. So the variable is x, which is equal to the unknown. It is what we need to find. The equation is, based on the information given in the question, the complete total perimeter, so the length of all the 4 equal sides, is 28 units. So if we add 2x plus 1 4 times, so 2x plus 1 plus 2x plus 1, we do that 4 times, we would find that it all equals to 28. So one way to show this, to translate this into an equation, is 2x plus 1 is equal to 28. Alternatively, a longer way to solve this is to rewrite 2x plus 1, and you rewrite that 4 times, adding it together. So now we're going to apply the distributive property as our brackets to simplify the expression on the left side. So 4 times 2x is 8x. 4 times 1 is plus 4, which is equal to 28. So now I'm going to remove the constant 4 by subtracting it on both sides, which gives me 8x on the left side is equal to 24. So now I have 8x on the left side. So to do the reverse operation of 8 times x would be to divide it. So 8x divided by 8. What I do on one side, I'll do to the other. Will give me 1x is equal to 24 divided by 8 is 3. Therefore, the value of x is 3 units. Question 4. The area of a rectangular bowling lane is 210 square feet. Find the value of x. Question 4. The area of a rectangular bowling lane is 210 square feet. Find the value of x. So the variable we need to find is x, which is the unknown. Now the equation, so based on the information in the question, we know that the total area of this rectangle is 210 square feet. So 3.5 times 6 times x, or 6x plus 18, will give me 210. Because the area is equal to length times width. So I know the area is 210, so I can sub that in for A. The width is 3.5 times the length, which is 6x plus 18. So now I'm going to solve for the x variable, and because there's parentheses on the right side, I'm going to apply the distributive property to eliminate the parentheses. So now I have 210 is equal to 3.5 times 6x, which is 21x, and then 3.5 times positive 18 is positive 63. So now I'm going to eliminate the 63 on the right side and as well on the left side. So 210 minus 63 is 147, which is equal to 21x. So now I'm going to divide 21x by 21 to isolate the x. The same on the other side. 147 divided by 21 will give me 7, which is the value of x. Therefore, the value of x is 7